teacher. This is my primary occupation, but I'm also the chairman of the planning commission in the city of Lowell. So that's another job of mine. We have 2 meetings a month that I lead. And then my third job is I am an ambassador for the medical company that got rid of my cancer 3 years ago because they had a new treatment that they developed. Kite Pharma company developed a new treatment, and I was one of the first patients to receive that after it was approved by the FDA. And since it was successful in getting rid of my cancer, they hired me to be an ambassador. So I speak to patients across the country who are going to be having the treatment and have questions, usually about side effects. That's what they usually ask about. So I speak to on the phone to many patients across the country. I also speak in Zoom meetings. In fact, I have one this evening when I get home, a Zoom meeting where I'll speak to a group of nurses and other medical providers and explain what it was like for me to go through the treatment. And so that's really fun, cool stuff to get to do. So the pharma company hires a company to handle all their ambassadors because they're a medical company. They don't deal with that. So they hire a company called Snow companies, contracts with medical companies. They're probably contracted with every medical company in the country, probably, but because they have lots and lots of people. They have like 400 employees that deal with all this kind of stuff. So I have an ambassador manager that works for Snow, and there's many other ambassador managers that work for Snow that are contracted with other medical companies. So Snow flew me into Virginia, and I spent a whole day with a film crew. Really cool. Director, sound guys, camera guys, makeup. There's like 10 or 12 people there. Just with me and my wife all day doing filming, interviewing me, asking about my what I do as an ambassador, and asking about going through the therapy and the treatment and all that. And they're going to edit all that together and put it on the website. So at some point, I don't know if it'll happen before school's out. They usually take a while to get all that put together. But they're going to have a feature on me on the website, letschatcart.com. Letschatcart.com. There's already some videos of me on that website that were made 2 years ago that they flew us out to Santa Monica, California for. So this time they flew us to Williamsburg, Virginia, and got to do that on Tuesday last week. So that was a lot of fun. And then on Wednesday, I got to go to the Snow Company, to their corporate headquarters, and I got to spend half an hour speaking to a bunch of their employees. The CEO was right in the front row. A lot of other ambassador managers were there that manage other companies' ambassadors. And they all got to hear me speak for half an hour and then ask a bunch of questions. It was probably the best day I've ever had in any job. I was on. I'm a storyteller by nature. I'm a storyteller. I'm very comfortable speaking in front of crowds. It doesn't bother me. Put me up there, give me a microphone and a spotlight. I'm a happy guy. So I was up there and just telling my story. And I was connecting with them. They were all just locked in. At times they cried, at times they laughed, but they were right there with me the whole time. And apparently they were texting. They got the group chat text thing too with my ambassador manager, who was not there because there was some other filming going on, so she had to be. But they were texting, "Whose ambassador is this? I would die for an ambassador like this." So it was really cool. The compliment she got. One of them asked her, "Can he come speak to my ambassadors?" Just to let you know, basically, I did such a great job of speaking that some of them have ambassadors. That's the thing. When you hire ambassadors, you're not looking for people that are great presenters and people that are great. You're looking for people that's had the treatment. So that's who you're limited to. I've had this treatment, so I'm in that pool of people they can hire as an ambassador. So, but you're limited to whoever the medical company was able to help. And that doesn't always mean that they're good storytellers. It doesn't mean they're comfortable speaking in front of groups. And so a lot of the ambassadors they end up with can tell their story, but they're probably reading a lot of it and they're very nervous and awkward in front of a group. And since I didn't have the problem, like, can he come speak to my ambassadors? The other managers asked, and I told her, I said, I'd be happy to go speak to other groups of ambassadors. I don't mind giving them tips on how to be a better speaker and how to tell their story. That'd be awesome. I'd love to do that. So I don't know, maybe I'll have opportunities to speak to other ambassadors for other medical companies through snow just because it went so very, very well. The CEO she was so excited and talking to me afterwards and really enjoyed my speech. So it was, like I say, probably the best day I've had in any job last Wednesday speaking to the Snow Company Corporation. But the compliments were just endless. One of them was saying, I really hated for it to end. I could have listened to him all day. So, and probably the best compliment I got is one of the employees there said, that was great to hear him speak. It reminded us of why we do what we do. So that was awesome. If I inspired them to continue on their job, then I did my job because that's what I do is just tell my story and inspire others through that, hopefully, to do better in what they do. So it was fun. I really enjoyed it. I love public speaking, especially if I know what the subject's about. And this subject is about me. So I know me pretty well and going through all that treatments for cancer. So fun stuff. All right. How many folks do we have? Well, it looks like we're missing 4 folks. So maybe they did not survive spring break. Maybe they partied out and have not been able to get out of bed since. I don't know. It was spring break. But I'm glad. We only got 8 weeks of school left. We are moving right on. Let's pull up this week. See what's going on. It's actually pretty short this week. That's why we got time to talk about any spring break stuff you guys did. But we'll take a look at it. Okay, Algebra 2. Let's go scroll to the grade screen. Get down here. We're through all the matrix stuff. And right before spring break, we started with simplifying rational expressions. If you remember that, it's basically taking 2 polynomials and putting them in a fraction, like x squared minus 6 divided by 2x squared plus 3x minus 1. Something like that would be a rational expression where you have 2 equations in a fraction form. So this week, we're going to look at discontinuities of rational expressions. And then next week, asymptotes, and finally solving rational equations will be later on in the month. So let's take a look. I'm going to go ahead and open up Desmos because we're going to need that. There we go. Oh, here's a little difference. So the object of a game at the festival is to get the ball from one end of the maze to the other end. And if the ball falls into one of the holes scattered on the maze, the game ends. So I don't know if they call these a labyrinth. I don't know if you've ever seen one. They're usually wooden, about the size of a computer, about the size of a laptop. They usually you can tilt them back and forth, or sometimes they have little controls on the side that makes it complete, go back and forth. But here's a little demonstration of how one works if you've never played with a labyrinth. So you got the little marble here at the start, and you roll it in there and see it goes to the left. You're trying to make it through the whole maze without falling into one of those little holes. And see, they fell in the hole, game over. It can be very frustrating, but you're just trying to get from one end to the other and out the exit without falling in one of those little holes. So I've played with several of those years ago. But all right, after this lesson, you'll be able to answer the following questions. How are discontinuities created in a rational expression? What are ways discontinuous points can be accounted for graphically? And how are zeros identified in a rational expression? So this is basically like a discontinuity. It'd be easy to go through the maze if there's no holes, right? But those holes are kind of representative of discontinuities. But anyway, we're going to have another video right here where we learn more about these discontinuities and what all goes on with that. So let me get this loaded up, get it ready to go.
We're going to take a look.
Hold on. Stop. 2 minutes, 47 seconds.
We're going to take a look at some things that occur with rational functions. Here we've got a rational function in the form of a fraction. And why might this be a problem? Well, what happens if the denominator ends up being equal to 0? The function will be undefined. So we need to make sure that we eliminate anything from our domain that could cause that sort of problem. So what do? Well, the easiest thing to do is simply take our denominator and set it equal to 0. Now if I solve this, I get x equals 1. Well, this means that a value of 1 for x will cause the function to be undefined. And so of course we have to leave that out of our domain. Now I don't see anything else that would be a problem, so in this case our domain is going to be all reals, except x is not equal to 1. All right? Let's look at another example. Let's look at f of x is equal to x plus 5 over x minus 3. Right? Now in this case we might be tempted to say, hey, we have the possibility of a 0 in the numerator, but that's really not a problem. 0 in the numerator just gives us a value of 0 for the fraction. We can graph that. It's a perfectly acceptable answer. The only thing we need to worry about is anything that would cause us a 0 in the denominator. So once again, we could set our denominator equal to 0. I think in this case you can see that a value of x equals 3 will give us a 0 in the denominator. And so our domain here is going to have to be all reals. X is not equal to 3. All right? Now let's look at one more. F of x is equal to 4 over x squared minus 5x plus 6. All right, now this denominator is a little bit more complex, but the principle is still the same. Take the denominator, set it equal to 0, and solve. Now, at this point, this is just solving an ordinary quadratic. So if we can factor, that would be the easiest way to go. And I believe this one will factor into x minus 2 times x minus 3. Okay? And so we could set each of these equal to 0, and we would find that x equals 2 and x equals 3 are the values of x that would cause our denominator to be equal to 0. So in this case, our domain is all reals. X is not equal to 2 or 3. And these are of interest to us because they're going to be related to asymptotes.
Okay. So that's a good look at problems with these equations, is that if you have 0 in the denominator, we can't divide by 0. Okay, so this wants to look at graphing. It says graph this rational function using the graphing software of your choosing. So we'll graph x squared plus 2x over x plus 2. So let's see.
I had a question real quick.
Yes.
So he said, like, on the last problem that he talked about, he got x minus 2, but he said that x cannot equal 2. Would it not be x cannot equal negative 2 instead?
Right?
Didn't he have x minus 2 and x minus 3? Was that what it was?
Mhm. So,
Well, if it's x minus 2, 2 is what would make that 0.
oh, okay, got it.
Right? Because 2 minus 2 would be 0. Yeah. Good question, though. All right, so x squared minus 2x. I think that's what it was. Let me double check. No, plus 2x. Plus 2x.
Connor, what are you sharing with me about?
Over x plus 2. Okay, so here is the graph of x squared plus 2x over x plus 2. And we look at it like, wait a minute, that's just a line. That's just a line. How is that just a line? Well, let's look at it another way. Let's start with the x squared plus 2x
I love that we have a rock collection.
over x plus 2. This is the equation I just graphed. It just looks like a line. In fact, it looks like a line that has a slope of 1. Yeah, I'm going to change this where it just shows the ones and not all the little lines in between there. See, it just has a slope of 1. It goes up 1 over 1, up 1 over 1, up 1 over, and it goes through the origin. This is just y equals x. That's just a line of y equals x. But the equation is x squared plus 2x over x plus 2. Well, let's factor this. X squared plus 2x. There's an x in both terms, so we can factor out an x. So x out of x squared be x. X out of 2x is 2. So the top factors to x times x plus 2. And the bottom is x plus 2. Well, if you have x plus 2 divided by x plus 2, that's just 1. Those cancel each other out because x plus 2 divided by x plus 2. So this just equals x. That's why it graphs as just y equals x. But when we look at it, we cannot have a 0 in the denominator. So if x plus 2 equals 0, there's a problem. So solving for x, x cannot equal negative 2. Because that would make a 0 in the bottom. So let's take a look at the graph again. Knowing that, let's say, okay, it just graphs as y equals x because that's what it simplifies to. That x plus 2 in the bottom cancels out. Open your software, customize the graphing area, enter the function, and after it, a graph will appear. Yes, and that's what our graph looks like. It looks like just a line. It says wait, it appears that it's a linear function and doesn't appear to be any breaks. When we look at that, there's just a solid line. And we said, wait a minute, x can't be negative 2, but it sure looks like there's x at negative 2. When we factor it all, we got down to just f of x equals x. They did the same thing, factoring out the x and x plus 2. But the problem is x can't be negative 2. Let's go back and look at this. So if I zoom in on this, and let's go down to x equals negative 2. There is a problem there. That is a hole in the graph. And if I click on that spot, look, it makes it a hole. It puts a solid hole. And interestingly enough, if you zoom in enough, which I just learned this yesterday when my students zoomed in farther than I zoomed in, you got to zoom in a long ways. But we're going to zoom in on this x equals negative 2. And when you get to a certain depth into the graph here, and when they're a long ways, wait a minute, get it, look, it's opening up. There is a hole in the graph. I had to zoom way in. Look, it's saying negative 2.000001. When I graph a long ways in here, it is undefined. Like it's undefined for our ways I've zoomed in so far. But we can actually see a break in the graph right there to where it does not exist. The graph stops and then starts again on the other side of negative 2. So you can zoom in far enough, but it's a lot of zooming to get there. And as I go back out, it'll eventually show it back together. Undefined. Oh, there's the 2 points that are supposedly the same point, that in between there, it's not defined. If I zoom out enough to put those back together here. There's the undefined. But yeah, you can zoom out enough to actually see the hole in the graph. But you got to get way in there. Yeah, x cannot be negative 2. All right, let's go to the next page. Look, there's not very many pages of this lesson. Said it was a very short one. In fact, at the bottom of page 2 is the lesson summary. So this is as far as this lesson is. I should have put more lessons together this week. We could have done more than one, but that's okay. It's coming off spring break. We're getting back into school mode. All right. So here's another look at the graph that we just did on the last page. And if we got closer, it should look like this. And that's what it did look like when I clicked on that spot on decimals. When I click on the 2, negative 2, it does put an empty hole there, which they illustrate right here. At negative 2, negative 2, the graph does not exist. It is undefined at that spot. It says the zeros of the function can be found by substituting 0 for f of x in the simplified rational function. So since f of x just equals x, it'd be x equals 0. And it does cross at 0. That's what crosses the x-axis. Or you can just look on the graph, it says. Well, look, yep, there's the 0. So in either case, the 0 of the function is at 0. So let's look at a couple more examples. All right, they want us to identify the discontinuities. It means where does the graph not exist? We want to identify the graph and find the zeros of this equation here. Okay, so if x minus 4 is our denominator, if that equals 0, solving for x, that would be when x equals 4. So x cannot be 4. So we found the discontinuity already. But let's simplify our equation as best as we can. For the top one, that will factor. We need two numbers that multiply together to be 12, but they add together to be -7. Well, if it's a positive 12, they have to both be negative in order for them to add to be a negative number. Well, the numbers that multiply to be a positive 12 and add to be -7 is x minus 3, x minus 4. So this factors real nicely. And then when we put the denominator on there, we see that x minus 4 divided by x minus 4 is just 1. So this simplifies to x minus 3. So to find the zeros, we can take the simplified expression, set it equal to 0, solve for x. This is the 0. So when we graph it, we should see it cross at x equals 3, and we should find a hole in the graph where x is at 4, because this does not exist. If we want to know exactly where that would be, we can substitute it back into this equation. 4 minus 3 is 1, so it's going to be at 4, 1. There's going to be a hole in the graph at 4, 1. That's what we should see when we graph it. So let's graph this equation back in Desmos. So this is x squared minus 7x plus 12 all over x minus 4. So look, the 0 is right there at 3 as we expected, all right? And we can see that in the graph, but we can solve it for x minus 3. And the hole is supposed to be here at 4, 1. And it is. It is undefined when x equals 4. So it puts a hollow circle right there at that point on our graph. So this is the graph of that equation. And it's basically the graph of x minus 3. Minus 3 is the y-intercept. It has a slope of 1 because it's just x minus 3. So 1x. So up 1 over 1. A 0 at 3. And a hole at 4. Oh, there it is. So they find the discontinuities. And they simplify it first. Find out that x minus 4, which was canceled, cannot equal 0. So they use the denominator to figure out what is not allowed. And then they substitute it back in to figure out it's the 0.41, which we looked at. Then they graph it. There's the graph. You got to make sure you use parentheses around the numerator and denominator for this to graph properly. See, I had to put that in parentheses. So it would put all of that in the numerator. And then plot that discontinuity. Use the open circle. The open circle is there. And then find the zeros. The simplified x minus 3. Set it equal to 0. And you find the zeros at x equals 3, which we also see on the graph. X equals 3. All right, let's look at another example here, and then we'll see the lesson summary. Okay, let me write this one down. Okay, this is our equation. F of x equals x to the third minus 4x squared minus 5x over x. So we can quickly see that x cannot be 0 because that's it. It's just an x. So this x can be any number except 0 because that would just be dividing by 0. Didn't have to do much work on that. This had x minus 4, so we had to figure out what x would equal. But this one's just x, so we just x equals 0. So let's factor this. x to the third minus 4x squared minus 5x, we can see that each term has an x in it. So that would factor to x times x squared minus 4x minus 5. Let's see, does this factor anymore? Numbers that multiply together be -5, so one be positive, one be negative, and add together be -4. Yes, so this would be x plus 1 times x minus 5. All over x. That's what it factors to. Right? Because 1 times -5 would be -5. 1 plus -5 would be -4. So this is the factors of that. So the x would cancel out. So the final equation would just be x plus 1, x minus 5, which that we can get the zeros from this, right? If we set this equal to 0, either x plus 1 equals 0 or x minus 5 equals 0. So one of the zeros is at -1 and the other one is at +5. That's our zeros. This is our discontinuity. That's our whole. This is our zeros. And this is going to graph like a quadratic equation because we got x times x. We have an x squared. So it's going to be a parabola. So let's put the original equation in the Desmos. And it should graph as a parabola since that x cancels out. So we're going to make this an x to the third power minus 4x squared minus 5x, all divided by x. Okay, there is the parabola. Have x to the third minus 4x squared minus 5x over x. So here's our rational expression. Here's what it graphs like. It's just like we expected. We have zeros at -1 and 5. That's our zeros. When we look at this, -1 and 5 are the zeros. So that is confirmed. The other thing it said is that x equals 0, at x equals 0 is our discontinuity. There's the 0. There it is, undefined. Yep, that's a hollow circle right there at 0 is not defined. Oops, getting off of it. There it is. 0 is undefined. There's a hole in the graph. And again, if we zoom way in, it'll show us a hole right there. But we got to zoom a long ways in before Desmos will ever show you that. So if you didn't know where it was, where you're looking, you could spend a long time zoom way in the wrong part of the graph. So you got to know where that is. What else did it want us to find? The discontinuities, the graph, and the zeros. We have all that. Let's look at this. Discontinuities. They simplify it first, but the x is what's in the denominator. The denominator x, which ends up being canceled, cannot equal 0. So x cannot be 0. If we want to find where that is, you can substitute that 0 back in there, and you get 0 plus 1 times 0 times -5. It's at -5. And we saw that here. We know at 0, we're at -5. It's just not defined. Oh. Have trouble hitting right on there. It is 0 undefined. But it's at 0, -5. Okay, the graph looks like that. It's a parabola. And there's a hole right there at 0, -5. And then find the zeros, -1 and 5, which we can also get off the graph. Just seeing where the graph crosses the x-axis. Okay, that takes us to the lesson summary. We just studied discontinuities, holes, places where the graph is not continuous. That's how our discontinuity is created. It's created by having values that are not part of the domain, which is whatever makes the denominator 0. What are way discontinuous points can be accounted for graphically? You put a hollow circle at that point in your graph to show that it is not included. How are the zeros identified? We take the simplified expression, set it equal to 0, and solve for x. The discontinuity of a rational function is a point on the graph of a function where the function does not exist. We can find it algebraically or by simplifying the function and finding the restrictions on the canceled common factors. A point of discontinuity is indicated by a graph, on a graph by an open circle. And the zeros can be found by substituting 0 for f of x and solving for x, most easily done in the simplified function. So let's look at some practice problems since it only took half an hour. We got plenty of time today. Identify the discontinuities, the graph, and the zeros of each rational function. All right, let's do a couple of these. I'm going to skip over and let's do the last two. Sometimes those are a little trickier. Turn our paper over. We'll do the last two and then look at the assignment. They want us to find what? The discontinuous graph and zeros, like all the others. So the discontinuity is going to be at x minus 2 equals 0. X cannot be 2. That's our discontinuity, right? Or a hole in the graph. Let's simplify this best we can. Now for this one, we have a 4x squared. So in order to find how this factors, we got to do factor by grouping. 4x squared minus 7x minus 2. So we got to find the factors. We got to multiply these together. 4 times negative 2. So we're finding the factors of negative 8, which are 1 and negative 8, or negative 1 and positive 8. 2 and negative 4, or negative 2 and positive 4. That's about it, right? Nothing else multiplies together to be negative 8. If we add these, we get negative 7, positive 7, negative 2, positive 2. And we need the ones that add together to be negative 7, so the first two. So we're going to rewrite this, 4x squared. Let's do plus 1x minus 8x minus 2. So you see, we just rewrote this as a plus 1x minus 8x. We didn't change anything, but instead of a negative 7x, we made it plus 1x and a minus 8x, which is the same thing, just rewritten differently. Now we'll group these. 4x squared plus 1x. Well, we can pull an x out of there, and that leaves 4x plus 1. All right, if we factor an x out of that, what can we factor out of this? Looks like a negative 2. Negative 2 factored out of negative 8x is 4x. Negative 2 out of negative 2 is just 1. So both terms have a 4x plus 1, so we'll factor that out. And what's left? X is left over here, and negative 2 is left over there. So this is that factors 2, and it's over x minus 2, right? That is the same equation as this. We just factored the top. And these cancel out. So this simplifies to just 4x plus 1. So the zeros is where 4x plus 1 equals 0. 4x equals negative 1. Divide by 4. So x equals negative 1/4. That's our 0. Okay, let's graph it. See what it looks like. Okay, our original equation was 4x squared minus 7x. I don't need the squared part. And it was minus 2. And it was all over x minus 2. All right. 4x squared minus 7x minus 2, x minus 2. So we said the 0 is at negative 1/4. There it is, negative 0.25. That's negative 1/4. And we said there's a hole at x equals 2. Oh, x equals 2. No, that'd be way over here. There it is. When x equals 2, there's a hole in the graph. It is undefined. So I would say we've done everything we need to do. We found the discontinuities. We've got the graph. We found the zeros. All right, let's look at the last one. By the way, what's the discontinuity? X cannot equal, this can't be 0. So if x is 1, 1 minus 1 is 0. So here's our hole right here. Where x is 1 is a hole. Let's simplify as best we can. So 3x squared minus 8x plus 5. So we have to find the factors. We're going to multiply these together. Factors of 15. And it needs to be a -8. So that means we would use both negative numbers. -1 and -15. -3, -5. Oh, wait, that works. That's -8. So we can say 3x squared minus 3x plus 5. Oh, not plus 5x. It's minus 5x. They're both minuses. Minus 5x plus 5. So we took -8x and we rewrote it as -3x minus 5x. Now we can group these. 3x squared minus 3x. Well, we can pull 3x out of there, and that leaves just an x minus 1. -5x plus 5. Let's pull a -5 out. -5x would factor out a -5. 5 factor out a -5 just leaves a -1. So we factor out -1 and 3x minus 5. And all of that is over x minus 1. Right? That's this equation up here. So this cancels out, which means it's going to be the graph of 3x minus 5 is what it's going to look like. To find our 0, 3x minus 5 equals 0. Add 5. 3x equals 5. Divide by 3. We have a 0 at x equals 5/3. So that's all we should see in our graph. We got a hole at x equals 1 and a 0 at x equals 5/3. Let's throw this in the Desmos. Yeah, if you're not graphing these, this will be a lot harder assignment. Plus 5. And x minus 1 this time. Hey, there it is. We said 5/3. That's the 0. 1.666667. That is 5/3. That's the 0 we expected. We also expect a hole at x equals 1. There it is. There's a hole at x equals 1. It is undefined. So that is, if you click on that, it'll give you the answers. There's the graph. There's a hole right there where x equals 1. X equals 5/3 is the 0 that we got. Well, 1, -2 is the point of discontinuity. And there's what the graph ends up simplifying to. X equals 3x minus 5. All right, let's look at the assignment. What are the zeros? They don't want the discontinuities with the zeros. You can graph that and find them very easily. Put that in Desmos, you can see the zeros. Or you can do it algebraically. What is the discontinuity? Okay, this is just to know what is not allowed. Where's the hole? This wants to know the discontinuity and the zero. Which graph represents this function? There's 4 graphs. They look very similar, but the holes are in different places. So if you can find out where the hole is and simplify the graph, you can put that in Desmos. It gets real easy. check to see where the hole is. And here's another one. Which graph represents this function? Another one, put in Desmos and check to see where the hole is. Is the hole there? Is the hole there? You know, because these two graphs are the same except for where the hole's at. These two graphs are the same. They both cross at 2. Just where's the hole at? So Desmos will help all of these, but you need to know how to do them algebraically. It'll help you. That's the assignment. You bet, Heidi. All right. Since that is our whole lesson, we'll use the rest of this class period to let you get this assignment done. Let's just get this knocked out. So that way you can do it while I'm available. When you finish this, you may be dismissed. You can leave when this is done, but spend the rest of this class period, and it shouldn't take you the rest of the class period, I would hope, to finish this, especially if you're using Desmos to look at your graph to find some of those key features as well. So take the time as soon as you're done with these 5 questions. Have a great week. If you need to be here Thursday and Friday, this is a B-Day week, so I will be here Thursday and Friday. And anyone whose grade is below 70, and I don't know that there's a whole lot of you whose grade is below 70, because nobody in here is missing like 10 assignments or nothing. You guys are doing a great job of keeping stuff turned in. So this is just another opportunity to stay on top of things by having this extra time in this class. So we've used half the class to give you the lesson. You have half the class left to do it. So I'm here if you have questions. I'll mute myself so that way you don't hear all these teachers talking in here, and you can get this done. And as soon as you're done, you can leave. If you have questions, you get stuck, speak up, raise your hand, put something in the chat, whatever you like, and I will be happy to answer. All right. Time is yours.